up to now, you guys have pretty much been graphing functions, test, even inverse trig functions or functions. And when you do that, then you would have in your graphing calculator, let's see, clear this out here. Okay, so your graphing calculator, you guys press your y equals, you'll see y equals. If you go into what's called the mode key, which is right here, press that. You're going to see choices, FUNC is function. Then there's things called parametric. That's the one I'm going to show you in a moment. Polar, you guys have seen polar. And sequence, which I never use it, but if you wanted to generate the dots in a geometric sequence, that somehow will do it, but who cares? Right now, I don't care. I don't care. I don't care. That one here, it's interesting. So if I go down and change my graphing mode to parametric and go y equals, you'll notice that there's x's and y's, x's and y's, x's and y's. So that's one thing to notice. The variable button, instead of being x, is now a t. If you're in polar, the variable button would be the theta, and if you're in sequence, the variable button's the letter n. So since I'm in parametric, it's the letter t. And what this is going to do, it's going to plot infinitely many points. Well, actually, it could be finite. It's going to plot a number of points that you tell the calculator to and connect the dots along the way. So what did I say? If I let t be anything, like how about t be 0, then the x coordinate and the y coordinate of the ordered pair would be 0, 0. If t is 5, this is absolute value, by the way. If t is 5, the x is 10 and the y is the absolute value is 5, so 10, 5. It would plot that. So it's going to plot a bunch of points. If I go here to window, I can tell the calculator, hey, only start at -3 to plot points. Only start at -3. Don't go anything lower than that. And stop when you get to the number 1. And then if t-step says, for instance, if I say, what did I say, -3. Clear that out. If I say, okay, t increments. Well, what that means is the calculator is going to plug in the -3, work it out, plot a point. And then it's going to jump by 1. So it's going to plug in the -2, plot the points, and connect the dots as you plot. Plug in the next jump by 1. So after -2, -1, plug in -1. Plug in -1 where? Over here. Put a -1 there, -1 there. So that's 2, 1. Plot the point. Connect the dots from the previous one. So you just keep doing it until you finally get to number 1. So if I hit graph right here, it's going to plot, let's see, when x is -3, -2, -1, 0, 1. It's going to plot 5 points and connect the dots. It did it really fast, but so it looks like it's doing this funny little thing here. Excuse me, I do have to take this phone real briefly. So.
I've been watching so many lectures to finish the semester. I just forgot we were live. Oops. I was like, oh, I'll just skip ahead to when his phone call's over.
Thank you. Sorry for the interruption or the commercial break. Okay, let's try this again. All right, I'm curious if I went into window and did this by threes. Okay. So if you do it by threes, it's going to plug in the -3, and then it's going to count 3 after that. So it'll plug in the number -3 and then 0. And then after that, it's beyond 1. So you're done. So it sounds like there'll be 2 dots. Connect the dots, so you're done. Let's see what happens here. Yeah. 1, 2, connect the dot. It threw away that part. Other places where parametric are kind of helpful is like drawing pictures of non-typical curves, or even things that are not functions, like circles. Those of you that, well, that's right, you're my math 27. So I can draw a circle with trig. See if I remember how to do that. I go y equals, clear that out. Cosine, x is always cosine, t, and y is sine t, and then I go, then t is a angle, so I have to go and look at my mode. My mode is in degree, that's fine. So then I go in my window, and I will let this be, this is degrees. I'm going to let this be 0 degrees to 360 degrees. And okay, now the steps are going to be the following. I'm going to make it 90. Then I'll tell you what's going to happen before it actually happens. And then I want, since it's a unit circle, I'm going to go from -2 to 2. -2 to 2. So it's going to be a circle of radius 1 that you guys already know about from this course. Now it's going to start at 0 and plot a point. So cosine of 0 is 0, sine of 0 is, no, cosine of 0 is 1 and sine of 0 is 0. It's going to plot 1, 0. Then it's going to jump by 90 degrees. So then cosine of 90 is 0 and sine of 90 is 1. So it's going to plot 5 dots and connect the dots. What image do you think it's going to produce? So will it be a circle with 5 dots or not? And if it's not a circle, what image do you think it might be?
No, it'll be a pentagon.
Okay, so a pentagon is a 5-sided. Okay, I get that. We'll see what it is if it's a 5-sided. Anybody else have a thought? I said it will plot 5 dots. That is correct. It will plot 5 dots. And then connect the dots. Okay, it's going to plot this one. It's going to plot this one. That's 90 degrees. It's going to plot this one. That's 180. It's going to plot this one. That's the 4th one. And then 360 back here. So it's going to go like this. Really fast. Really fast. If I changed my steps to 45 degrees, so it's going to plot those other angles and connect the dots, it's going to get closer to the circle, but it's still not going to be a circle. So if you want it to be a circle, first of all, it's a rectangular screen anyway. Then you got to plot more points. So you go in Window and you make this. What if I made this 1 degree? Well, it's going to do 361 ordered pairs. Now the ordered pair comes from, you got x equals cosine t, y equals sine t. Now this is going to go slower because it's plotting a bunch of points. So let's see. It takes a while for it to think and plot, but eventually it'll get there. So I've just plotted a circle, or drew a circle, but it's not a function, so you don't do it with y equals. And then in calculus, your 1B, you're going to do a bunch of calculus on a whole chapter's worth of what's called parametric equations. And ideally, your instructor will do a brief introduction and then jump right into the calculus on how to do this again. So that's about a year from now for most of you. No, probably less than that. If you take your 1A, that's right, your Math 27, you take your 1A in the spring, you'll probably take your 1B in the fall. So it'll be 9 months from now. So that's good. No parametric equations on the final exam, and you don't have to turn your, wrong binder. Oh, well. You don't have to turn your homework in on it either. Shoot, I've got the wrong, it's a brand new binder. I suppose I can just go ahead and do it. This is a brand new one. The last section we do is I think it's 2.7. So 2.7 for you guys. I haven't done this, have I? All right, I'm going to look at my assignment schedule. It's going to force me to do that. Here it is.
You haven't done 2.7.
So yeah, I'm going to do 2.7 right now. And now I got to find you guys again. Here you are. Okay, polynomials. Okay, this is a polynomial. This is actually a quadratic right here. I said, check this out with the calculator. Your author does something similar. He goes y equals 2x squared plus x. He'll make that the first one, then he'll go y equals 15. So he'll graph both of these simultaneously. Change my mode. So that's a horizontal line, that's a parabola. Window, I'm going to go from negative 30 to 30, and tick marks of 5, negative 30 to 30. Now, the image that you see here says all the answers from the parabola on the right-hand side, that means all the y values have to be bigger than 15. All the y values, all these y values have to be bigger than those y values are 15. So if you zoom in here, visually, what that says is, okay, here's 15, all the y values. So your answers are on these two little pieces right here. So I'm going to give you, and the answers have to be the x value. So it'd be from negative infinity up to wherever this is, right there. Where is there? I could find that with my graphing calculator using the intersect key. Where is there, Jeff? Okay, if I do intersect, first curve, second curve. So at -3, and this is probably at +3. So at -3, so -infinity to -3, and then from +3 to infinity, the curve is above or greater than the line. So I'm going to take a stab at the answer from the graphing calculator that my solutions lie from -infinity to -3, and then you go union, and then 3 to infinity. Now, the reason why I put parentheses around this is because the inequality doesn't have a bracket. So in part, it has a connection to your inequality section, which was, I think it was in P7 or P9. And then you get some quadratic stuff. And I haven't shown you graphically how that worked before, but I'm going to look at this answer. And unions, we've done unions before. Now the algebra method, that's what probably most of you are wanting to do, is the algebra. The algebra method is to get it set equal to 0. So get what set equal to 0. Take this and set that equal, well, let's say take this and get an equal sign right here, which is 2x squared plus x is equal to 15. So first solve the equation, make sure it's set equal to 0. Then I can go, okay, 2x squared plus x subtract 15 is equal to 0. And how to solve this, you would factor, you'd hope it factors. I think it does. 5 and 3, 5 and 3, 5 and 3, 5 and 3. I think a 5's here and a 3 there. This is a plus and that's a negative. Yep. Factored it correctly. Or you could have used the quadratic formula, which I'm not going to do. Solving this for x, you get x is equal to 5/2. Solving this for x, I'm gonna have to check this one. This one I got from the calculator. Yeah, I got a little sloppy. This one I need to check. This one came from the calculator, right here, -3. But I just got a little sloppy because I thought it was going to be 3 again, and it's actually not. Here, I'll do this with my calculator again. That place of intersection is going to be 2.5. It's going to be 5/2. Move my cursor. Yep, see 2.5. So I've got a little sloppy there. This needs to be 2.5. No parentheses. So I think that's the right answer. And then what happens is there's your 2.5 and here's your -3. So on a number line, you'd have -3, you'd have 2.5, and you got 1, 2, 3 regions to determine if there's a solution in any of those regions. So you do what's called a test point. That's what the author shows you too. You take a test point, something that's to this region over to the left of -3. So if I say test, say -5, you put in -5 into the original. The author actually says the same thing. I showed this to my my other class, my math, what was it, math 27? 27, 25, math 25 class. Unless I dreamt it. I don't think I did. Oh, huh. I might have, here's my instructions up here, but I'll show you the textbook too. Okay, find the boundary numbers, which I just did. Boundary numbers was 2.5 and -3. Draw a number line, which I did. Put the boundary numbers down, which I did. You've got 3 intervals. Do a test value, which I'm doing. And you evaluate the f of x. So this is your f of x that I'm asking you to evaluate actually here. But when I say evaluate this f of x, I want you to do it up here. You want true. You don't want false. You want true. So if I go up to here and I say, how do I know if it's true or false? You go 2 times -5 squared plus -5 greater than 15. I don't know. Is it true or false? Okay, that's positive 25 times 2 is 50. 50 subtract -5 is 45. Is that bigger than 15? Yes, that's true. So over here, since that was true, test point, then all of that's true. So you said, well, what about over here? How about test? How about test 0? So go back to the original. Put a 0. 0 is 0 bigger than 15? No. No. So this would be like T for true. This would be F for false. And you would think this is going to be T for true. So if you tried, say, +5, try +5 as your test point, and you put 5 right back in here, that would be 55 is bigger than 15, and that's going to be true. So squiggle, squiggle, squiggle. So the author goes through an algebraic and graphical representation that way, rather than graphing the 2 pieces and seeing whether something is above or below the other part. Above the other part, which is this one here, the line. It can be hard for some of you to get the graphing part of it. So you do the algebra. And then, of course, you get your answers that look like this. So I'm going to do the algebra. I'm not going to do the graphing. I'm going to do the algebra. So this is your solution. Solve that. There's your solution. Yeah, you don't need to know this right here. I'm thinking, don't do it that way. Okay, this one, solve this one, Jeff. Sure, okay, x cubed plus 2x squared plus x plus 2 is less than or equal to 0. And now I'm going to go ahead and do the factoring. And here's something you haven't done for a while, I'm sure, grouping method. Factoring, I don't know how else you do it, but grouping method. So I'm going to group these 2 together. And this plus goes here, so plus x plus 2. This is how I teach my algebra students about grouping, and this will always be a plus sign. I always teach my students, throw the parentheses around the signs. See, some of you are going to do like this. It's a typical mistake. You want to group here. I totally get that, and that's not the mistake right there. But then you're going to go like this. And that. But Jeff, isn't that the same? Yes, but what happens if that was a negative to begin with? That's the problem you'll get into. You're going to slice off the negative and forget this one over here. So if you want a little explanation about what I did with grouping, see me after class. I'll step through the algebra one more time with you. GCF here is x squared. You get an x plus 2. Well, no GCF. Except there's a 1 on the left-hand side. Oh, okay, so you got parentheses x plus 2 parentheses x squared plus 1 less than or equal to 0. And then if I set these each equal to 0, I get boundary, B-O-U-N-D-R, boundary points. One's going to be x equals -2. Now, if I set x squared plus 1 equal to 0, hopefully all of you are going to see you're going to get an imaginary number. You go x plus 1 equals 0, solve for x. So you get x squared equals -1. And if you take the square root of both sides, you get imaginary. So we're not talking imaginary here, just real. That's the only boundary number. So you go like this. Here's -2. You test over here. Let's say -4. Test over here. Let's say 4. And you test it up here. So you go -4 cubed. I wonder if that's less than -2 times -4 squared minus a -4, subtract 2. I wonder if -64 is less than -2 times 16 is 32 plus 4. Yes, this is going to be less than -2. So this is a yes. I can see that's going to be yes. So squiggle, shade. Okay, try another one, 4. So then you go test x is equal to 4. Go 4 cubed, less than or equal to -2 times 4 squared minus 4 minus 2. I wonder if 64 is less than whatever's over here, and it's not. It's false. No. So don't shade over there. So this is the only place where the answers are. So your answer is -infinity to -2. And is it bracket or parentheses? It's a bracket because there's an equal sign. Okay, those two were called those two were called polynomial inequalities. This is called a rational inequality because there's a fraction downstairs. Rational inequality, rational. Let's see, on the rational, right here. On the rational, if it's a rational, you set both the numerator and the denominator equal to 0. You're looking for where the numerator is equal to 0, which makes it 0. But when the denominator is 0, it's undefined. So they're both called boundary numbers. But you got to get everything to the left-hand side and with this is already set up. So 0's on the right-hand side already. This one's already set up. This one's not. I got to bring the 2 over to the left-hand side. This one's already set up. So boundary probably ARY, boundary. You go x minus 4 equal to 0. You get x subtract 3 equal to 0. X is equal to 4. X is equal to 3. Line 3, 4. Test. How about -1? How about test in here? Ooh, how about 3.5? 3.5. Over here, how about 5? So when I test x is equal to -1, then you're going to put it here. -1 subtract 4 over -1 subtract 3. I wonder if it's greater or equal to 0? Question mark. Is -5 over -4 greater than or equal to 0? Question mark. I think it is. That's positive 5/4. That's bigger than 0. So this is true or yes. So that was over here. So squiggle, squiggle, squiggle. That's all the answers are over there. Okay, the next number that I'm testing is 3.5. So x is equal to 3.5. Put it in the original again. So back up to where my thumb is. 3.5 subtract 4 over 3.5 subtract 3. I wonder if that's bigger than or equal to 0. That's negative 0.5. Down here is positive 0.5. Greater than or equal to 0? Question mark. Huh. Well, that's -1. That's false. That's not less than 0. -1 is, yeah, -1 is supposed to be less than 0. This is greater than 0. That's false. This is false. So don't shade in here. And you'd probably think there's a pattern here, that if it's true here, false there, true, it alternates back and forth. Let's test it though. How about x is equal to 5? And then you go 5 subtract 4 over 5 subtract 3. That's what, 1 over 2? And the question is that greater than or equal to 0? And it is. That's true. So this is true. So squiggle, squiggle. And then you do your interval notation, which that's where they put the union in there. The interval notation. Okay, so from -infinity, you got -infinity to 3, and it's a bracket here, and then union, and then bracket. Start up again at 4, and then go to infinity. And this is your solution. Solution region. I'll do this one down here. This one requires that I put the 2 in the left-hand side. That's my suggestion. So you're going to go x plus 1 over x plus 3, subtract 2, greater than 0. And then the trick is common denominator. You want to squish the two things together as one fraction. Common denominator. That means x plus 3 to both. So I have x plus 1 over x plus 3, subtract 2 parentheses x plus 3 over x plus 3, greater than 0. So that's x plus 1. Okay, so you're going to take the negative and the 2 and give it here. And the negative and the 2 and give it over there. Collect like terms, so negative x minus 5. I haven't made a careless arithmetic mistake. Let's see, x minus 2x is negative x, 2x, 6, both negatives. I think I did that okay. Then you take the numerator, set it equal to 0, and the denominator. So take this, set that equal to 0. So -5 is one of the boundary numbers, and then this one here would be -3. X plus 3 equals 0. So then you get that, and then you get x equals -3. Those are your boundary numbers. Make your number line. -3, -5, -3, -5. All right, test here. How about, oh, I got those backwards. Silly me. I got those backwards. -5 is first. That's smaller, more negative. Yeah, so -5, -3, about -6, -4, and -1. Or 0. 0 would have been nice. So I'll do those. So at -6, I just have to see if it's true or not. Back into the original here. So I go -6. So -6 plus 1 over -6 plus 3. Let's see, -5 over -3. -5 over -3, which is 5 over 3. But the question is it bigger than 2? Is that bigger than 2? I don't think so. That's not true. Yeah, that's 1 2/3. Yeah, it's not bigger. So I'm not going to shade that region. So this is false. Okay, the next one I'll try -4. So -4 plus 1 over -4 plus 3, which is -3 over -1, which is 3, and that's bigger than 2. This is true. That's true. So in here, so no, yes, no. You'd think this is a no. That's what I would think. Because there's a pattern to it, you know. If it starts with yes, then it kind of jumps, alternates. So I'm going to try -1 just to make sure. Put -1 top and bottom. So if you go up here, if I put -1 in, so -1 plus 1 over -1 plus 3, that's 0 over 2, which is 0. Is that bigger than 2? Question mark. No. So don't shade. So the answer is right here in the middle. So solution or solutions are from, okay, parentheses. So parentheses -5 to -3. Those are your solutions. So in a way, mechanical. In a way, if I looked at the graphing calculator right here, you wanted for the last one here for graphing. If I graph this on the left-hand side is the first one. And did the fraction thing here that I have, which is x plus 1, x plus 3. And then do 2 and change my window maybe, how about -7 to 7? See what happens. Let's see. I can see my answers from -5 to 3. That would be over here, -5 to 3. -5 and -3. So I'm supposed to look at where it's bigger than 2. Now, 2 is right here, the horizontal line. Where's bigger than 2? Above 2, right here. It's the only place where it's sitting. Okay, so you can see it's -1, -2, -3. There's a horizontal or a vertical line right here. This piece right here is the only place that's above. And that turns out to be from -5 to -3, where the undefinedness is. Harder to see. See the graph? This one's a harder to see one. This made more sense to me if I was a student. This makes more sense, pretty mechanical. So I'm not going to do the last one because the last one's similar. It's just factoring is all it is. You guys can do the factoring. This last section that I just finished up, I gave you 4, maybe 5 good examples. Don't do the graphing. You don't need to do the graphing calculator idea. Do the algebra on the group quiz. If you pick this one, show me the algebra, show me the test points. You know, more is better. This could be on the final exam 2.7, but the parametric, not going to be in the final exam. I can tell you that right now. So you do want to do 2.7. You do want to do that. Homework. All right, what questions do you have of me?
So just to clarify, for homework, we're not doing section 9.5, only 2.7?
Correct.
Thank you.
Welcome. I'm curious as to how many of you think that you will either, well, you won't be here on Thursday because you're either not taking the group quiz or you're going to do it on your own and submit it. So you're just not going to show up on Thursday. Curious to see how many people are thinking that for Thursday. You can change your mind. I don't care, but
well, I have a question. So you sort of, I'm still a bit confused about whether who has to, like, for instance, would I still get any points by doing the group quiz or?
okay, your microphone was kind of, I don't know if anybody else heard it. It was kind of echoey. If that's, I kind of heard it that way. Try it again, Matthew.
Well, I mean, maybe this isn't the appropriate time to ask, but like, for instance, would I like get any points by doing the group quiz over?
If you did your group quiz on your own,
Yeah.
home, and not showed up for the Thursday, and you submitted me your results, you get credit for it.
Yeah.
The benefit of coming on Thursday is if you're stuck on anything and maybe somebody else has some ideas on how to unstick you, you might get a benefit out of that. And also you share your own opinions and ideas too. So no, but you'll get credit for doing it on your own. I'm not taking roll. You've noticed I haven't taken roll ever for a long time.
Yeah. Yeah.
Okay, so it sounds like maybe Matthew's not sure. He's thinking about maybe not showing up, but that's okay.
No, I like, if I do it, I do intend to show up, but like, I was wondering, like, is like the quiz in general,
Is the quiz in general what?
would I get points for that period?
Well, you get points if you end up turning in something to me.
Yeah, okay. I think I got it now.
Yeah, and I'll grade it like I have the other 3 group quiz. I'll grade it and get those scores back to you as soon as I can, before the final, ideally. You get one to throw away. Remember, you got a group quiz to throw away. If there's some of you may have already gotten 25 out of 25 for the first 3 group quizzes, you can't get any more points. You're at the max. I'm not telling you not to do the group quiz. I'm just saying you can't get any more points. So that might be a reason not to show up and just say, well, I'll do the quiz on my own, but why be here? So doesn't matter to me. I'm going to be here to administer the group quiz, not administer it, just help guide you, put you in little rooms and be here. So it's up to you guys. All right, well, I don't have anything else for today. Today's that last short day. Got an hour's worth of lecturing, that's it. Anything else for me? You can stick around and ask me questions one-on-one or 1-on-4, whoever's here. Homework questions, if you're stuck on anything, I can do that.
I mean, I do want to say, just